Hello, everyone, and I hope everyone is doing well. And today we're going to continue talking about redox reactions. See, in redox reactions, it is beneficial to treat all bonds as ionic bonds, kind of. So whenever we look at any compound, we're going to pretend. We pretend that all compounds are ionically bonded. Right? And the reason we do that is it allows us to follow the path of the electrons. Right? So electrochemistry is all about what's happening with the electrons, right? So we want to be able to follow where the electrons start from and where they end. So what we're going to do is we're going to give all numbers, but we're going to give every element what we call a oxidation number. I know a lot of you were asking me, Mr. Schreiber, on the reference table, I think I have the copy. No, don't have it here. On the reference table, why do they call it selective oxidation state instead of a charge? That's why. It's because they're oxidation numbers. Oxidation number is a number we give to all elements as if all bonds were ionic. Right? So we got some rules. How to find oxidation numbers. Right? Okay. So first thing we should know is that all compounds have a net of 0. If you add up all the oxidation numbers in a compound, that net is 0. All polyatomic ions oxidation numbers add up to the total charge of the polyatomic ion. And then all elements in their elemental form have an oxidation state of 0. Have a oxidation number of 0. Finally, lower electronegativity element will have a positive oxidation number. Now, we have some trends. to finding those oxidation numbers. But as a general rule, use your reference table. Here are our trends. All right. Group 1 will be +1. Group 2 will be +2. These are like always true. Or at least the group 1 metals and the group 2 metals. Group 17 can be -1. Group 16 will be -2. Group 15 will be -3. Group 14 will be -4. Okay. So let's look at some examples. We can start with sulfuric acid. So I want to find the oxidation state of each element here. And I know they all add up to neutral, right? So H is in our group 1. Up here, it has the lowest oxidation state. It's going to be an oxidation state of +1. Now there are 2 of them, so what I'm going to write is +1 times 2. And then my oxygen. Go over to oxygen. So oxygen, like always, -2. -2 times 4. And then you will note that if I do this out, this is a 2, this is a -8. So I need to find what are x's here, right? So 2 plus something equals -8. So S therefore has to be +6. Not too hard, right? Let's try another one. LiNO3. Li is a group 1 element. +1. Oxygen, as we discussed before, is a group 16. It has a -2, so -2 times 3. So we got -6, +1, which means that N has to be +5. Next one, here we go. Ca3PO4. Ca. Ca is a +2 times 3. PO4 is a -2. I'm sorry, O4 is a -2 times 4. So over here we have -8. Over here we have +6. P has to be +2. Oxidation states. Okay. Thank you so much for watching. I hope everyone has a wonderful rest of the day. Bye all.